I started this section talking about how Java has several ways to support abstraction. You saw that an abstract class requires its subclasses to implement its abstract methods. An interface is similar to an abstract class, although it isn't a class at all. It's a special type that's more like a contract between the class and client code that the compiler enforces. By declaring it's using an interface, your class must implement all the abstract methods on the interface. A class agrees to this because it wants to be known by that type by the outside world or client code. An interface lets classes that might have little else in common be recognized as a special reference type. I'll be talking about the benefits of interfaces quite a bit as we work through the next couple of videos. Declaring an interface is similar to declaring a class using the keyword interface where you would use the keyword class. On this slide, I'm declaring a public interface named Flight Enabled. An interface is usually named according to the set of behaviors it describes. Many interfaces will end in able, like comparable and iterable, meaning something is capable or can perform a given set of behaviors. A class is associated to an interface by using the implements clause in the class declaration. In this example, the class bird implements the flight-enabled interface. Because of this declaration, we can use flight-enabled as the reference type and assign it an instance of bird. In this code sample, I create a new bird object but assign it to the flight-enabled variable named flyer. Let's look at this interesting type in some code. I've created a new project called Interfaces. I'm going to first create a class in that same package and call it Animal. Once created, I'll make it abstract by adding the abstract keyword. I'll include two interfaces in this same source file, interface flight enabled and interface trackable. Next, I want a new class named Bird in the same package. And I'll extend the animal class and implement both interfaces. What's important to see from this declaration is that we can use both extends and implements in the same class declaration. A class can only extend a single class, which is why Java supports only single inheritance. However, a class can implement many interfaces, providing flexibility and modularity. This allows for the combination of different sets of behaviors, making interfaces a powerful feature. A class can both extend another class and implement one or more interfaces. In this example, the bird class extends or inherits from animal, but it's implementing both a flight-enabled and trackable interface. We can describe bird by what it is and what it does. Now that we have this bird class, I want to get back to the main method on main and create an instance of this class. This is the usual way to create a new instance of bird and assign it to a reference variable bird. But we can say a bird is an animal and that it's also flight-enabled and trackable. That means I can assign my bird object to different reference types, which I'll do now. First, I'll assign the bird object to a variable of type animal, then flight-enabled, and then trackable. A bird, as it turns out, can be assigned to any of these four different types. I've got all this set up, but none of it's very interesting without adding some methods. I'll start by going back to the animal abstract class and adding an abstract method there, public abstract void move. Remember that an abstract method on an abstract class has to be declared with the abstract keyword. This causes our bird class to have a compiler error because we haven't implemented that method on bird yet. Let me do that using IntelliJ's tools to produce the default implementation. Let's put in a print statement so we know when the method is invoked. Going back to the main method, I want to call this new method on some of our variables. Animal.move using the animal reference, flyer.move using the flight-enabled reference, and then tracked.move using the trackable reference. Note that only the first call to move compiles, the other two don't. I've talked about this and I want to review this again, so you are clear on why this is happening. The type you use, meaning the variable's declared type, determines which methods you can call in your code. When we assign the bird object to the flight-enabled and trackable variables, those types don't have a move method on them, so this is why we get this error. The compiler only cares about the declared type. I'll comment out those last two lines. Let's run this now. The output confirms that this animal, which is really a bird instance, flaps its wings. Okay, now I want to add some methods related to flying. on the flight-enabled interface, public abstract void takeoff, abstract void land, void fly. I have 3 methods here, and you can see this code compiles. None of these methods have a method body, but we haven't used the abstract modifier on the fly method, so why is this still okay? Why does it compile? I don't have to declare the interface type abstract because this modifier is implicitly declared for all interfaces. Likewise, I don't have to declare any method abstract. In fact, any method declared without a body is really implicitly declared both public and abstract. The 3 declarations shown on this slide result in the same thing under the covers. If I hover over the public modifier in the first statement, you can see the message, modifier public is redundant for interface members. I'll mouse over the abstract modifier in the second statement, and this time modifier abstract is redundant. So these declarations are all the same. But now if I change public to protected in that first statement, this time I do get a compiler error because modifier protected is not allowed here. If you omit an access modifier on a class member, it's implicitly package private. If you omit an access modifier on an interface member, it's implicitly public. This is an important difference and one you need to remember. Changing the access modifier of a method to protected on an interface is a compiler error, whether the method is concrete or abstract. Only a concrete method can have private access. Let's go back to the code and remove those modifiers. And while I'm in this source file, I'll add a method to the trackable interface, void track. What's wrong with this code? Well, every method on an interface is assumed to be public and abstract, unless otherwise specified, and in this case I've included a method body. The method body means something is wrong. Either this method is missing a more meaningful body, or the method body shouldn't be here. I'll be talking about concrete methods on an interface shortly. For now, I'll remove those curly braces and replace it with a semicolon. What good is a type that has methods that don't do anything? Why is this such a powerful thing? Let's get back to the bird class to find out why. Similar to the way an abstract class forces its subclasses to implement the abstract methods it declares, the interface requires any classes that implement it to do the same. This class, because it implements these 2 interfaces, now has to implement the 3 methods on flight enabled and the 1 method on trackable. And like an abstract class, we can do the same by hovering over that error and selecting implement methods. I'll pick all 4 methods there in the pop-up. And just like it did for an abstract class, IntelliJ generates method shells for all the abstract methods for all the interfaces this class implements. To keep this simple, I'm just going to print something out in each of these methods. So for the takeoff method, here I'm printing out the class simple name, not the fully qualified name, and then the text is taking off. I'll copy that statement and paste it into the other methods. In the land method, I'll change what gets printed to is landing. In the fly method, I'll make that is flying. And finally, in the track method, I want to print out that the coordinates were recorded. Speaking of that method, if we implemented it in a real application, while something is flying or is in transit, this might periodically send its coordinates to the application. This would make it possible to track the flight path of this bird, for example. Let's add calls to these methods in the main method. Fly.takeoff, fly.fly, track.track, fly.land. Running this now. You can see that all of Bird's methods were called. In this code, we have a variable flyer of type flight enabled, and when we call any flight enabled methods on that variable, it executes Bird's methods, because Bird is our runtime object. And the same thing with trackable. We can describe a bird in many ways now in the code, treating it as a member of multiple and quite different groups. I don't want this video to get too long, so I'll stop it here. In the next video, I'll continue to examine the interface type and detail why it's such a powerful feature in Java. I'll see you in the next video.